that we are going to cover, right? We are actually going to
Okay.
start with the Linux basics, but in your case, I don't think you need them. It's just the basic commands. Basic commands
Mm.
and some user management topics with some permission topics, right?
Okay.
Something you might not need. And this is a 2 days class, 2 or 3 days class. And after that, we will move
Okay.
on to Linux administration training,
Okay.
where we are actually covering the installations in Linux, then web application software and web applications, some introduction. What is a web application? How you can set up a web application and run it on a Linux machine, right?
Okay.
Apache is a web server, maybe you already know. And we are covering some
Mm.
PHP framework, Tomcat, and some Java applications and some Java sample applications we are covering. And we will also see how a web application can connect to a database, all these things. This is the very basic into DevOps. I mean, right? Uh,
Mm.
for learning DevOps, you need to understand how to deploy these applications in a manual way, right? How to set up these softwares and how to install these applications, and basically how you can run your own web applications. Something like, right? All Google.com,
Mm.
Flipkart.com, all these are examples of web applications, right? Any software
Okay.
that you get through web, it's an example of web application. So we will see how we can set up a sample web application ourselves, and how you can set up that web application in a Linux environment.
Okay.
And then we will move on to some networking basics. Also, this this all these classes would take nearly 5 hours, and then we will move on to networking basics. That is
Okay.
also I'm expecting nearly 5 hours. We will cover about some DNS principles, some network, right? We will see this is also
Mm.
very essential before you start with. I mean, the very
Okay.
basic to DevOps. What is DNS? What is network? How you can set up a traditional network like an office network? How you can set that up, right? And all these
Okay.
things we are covering during this session. And once we are done with Linux administration and networking basics, we will move on to cloud computing. Under cloud computing, we are covering AWS. These are the services that we are going to cover: EC2, ELB, auto scaling, VPC, IAM, S3, CloudWatch, Route 53, SES, CloudFront, RDS, then some command line tools. So
Mm.
basically, uh, AWS is a cloud computing provider. From them, you can actually get the services, whatever that you need. You can create them as a service. For example, the Linux machines, Windows
Mm.
machines, the networks, right? Then the storage devices, databases, all these things you can get them from AWS as a service. So we will see how you can get them as a service and how you can build your infrastructure in the cloud.
Okay.
And we will then, after building that infrastructure in the cloud, we will deploy these web application which you have developed, the PHP one and the Java one. Those web applications, we will deploy them into this cloud infrastructure that you have set up, and that is going
Mm.
to be your first project. And after we are done with cloud computing, we will move on to the DevOps tools training, where we are covering these many tools: GitHub, GitLab, and Jenkins, Docker, Nagios, Chef, Puppet, and Ansible. These are the main tools we are going to cover under the DevOps title, and we will have a final overview about other tools out there for DevOps. There are lots of them. So we will see which are the popular tools in DevOps and how that can help you achieve these DevOps practices. And then we are also covering scripting, shell scripting we are covering in detail, Python programming we are covering the basics. I mean, not the basics
Okay.
actually, we are covering the topics which are specific to, especially the modules, and object oriented programming is what we are going to focus on. when we learn Python programming,
Mm-hmm.
right? So it's a total 60 hours training. It would take uh, three projects. First project is into cloud
Okay.
computing, AWS.
Mm-hmm.
That's for building an infrastructure. It will have multiple Linux machines, and you are going to run your web application, the one which you have set up, the PHP framework and the Java application. Those application you are going to run inside this cloud environment that you have set up,
Okay.
right? And hey, Tanmay. Uh, then in DevOps we have two projects. First project is continuous integration. Then
Mm-hmm.
last project is config management using one of these tools. And
Okay.
I will talk about the project in detail.
Mm.
Before that, I would give you an overview about cloud computing. Cloud computing and DevOps. Okay, somebody joined the meeting. Okay, so we will talk about cloud computing. Kamalakar, yeah, Kamalakar. Do you have any experience into IT? What experience have you got?
Uh, no, I do not have any experience in IT right now, but I'm I know all the tools, but I'm not completely onto it. So I'm looking forward for your training.
Okay,
Yeah,
yeah, cool. So this I was discussing about the topic list that we are going to cover.
yeah, yeah.
I don't know
Okay,
how much of you were part of.
I see that. Yeah,
Okay, cool. So now we will talk about what is cloud computing. Just a quick introduction.
okay,
So think about any infrastructure, right? Think about any infrastructure that you need. Probably you need an infrastructure for your company employees, right? In every office you would find an infrastructure. It contains many computers connected to each other, and there are a lot of networking devices and your employees laptops connected to it. It's an example of a infrastructure, right? Your office network or your college network. All these are examples of infrastructures. And similarly, every companies need an infrastructure where they need to run their software. For example, think about Google or any company. Think about any company. They all need an infrastructure where they want to run the softwares, run their web application. Google has the google.com web application. So they need a number of machines working together that serve this web application to the users. Maybe that infrastructure can contain multiple machines connected to the same network, and these machines are getting requests from, let's say you browse for google.com in your browser, your request is coming into this machine. This is the machine that contains, it is running some software component which save the content of the google.com web page, and when you request for google.com page you are getting it from this machine. And then you are trying to search for some terms. You are trying to search for some right, you want to search for something in Google. You put the search that you want to do, you put the string in it, then probably this is the machine which is responsible for running the search algorithm. So the request is sent to this machine. This machine will run the search algorithm. It will run lot of commands, and it will generate the database query using which it can fetch the search result from a database. Then it will run the database query, get the result from a database machine. This is a database machine. So finally, the search result are now displayed on user browser. So what I'm trying to say is there can be multiple machines. There can be multiple machines working together in any infrastructure that is serving a software. And you will also have, right, sometimes you have lot of traffic coming into your infrastructure, because think about google.com. People from all over the world are browsing for google.com. So it is important that google actually have a number of machines, right, a number of machines which will serve all these users. So if there are millions of people browsing for google.com, there should be hundreds of machines in google's infrastructure which can handle such a big traffic. So depending on many factors, there the size of the infrastructure can vary, and there can be many things. It's not only the machine that you would see in the infrastructure. There can be Linux machines, Windows machine. You would also see some storage devices. You would see some databases. You would see this network where all the machines are connected to. Then the network is split into small subnets. You would see a lot of things, and there can be some load balancers which will make sure that all machines are getting equal traffic. So there can be many things that you can find in a typical infrastructure. So if you have to set up, let's say for any company who has a software needs such an infrastructure so that they can serve the software to people, any internet software, right? The examples are Google, Flipkart, right? Amazon, anything, any company, any startup companies also who has a software, they need an infrastructure where they want to run their software. So if you have to set up such an infrastructure of your own, what all things you would need, just think about it. If you have to set it up your own, you need a lot of things. You need a big building where you can keep all these machines. They are typically called data centers, and inside these data centers you need to buy the machines and keep the machines, and then you need lot of network devices to create the network, right? All machines need to be connected to the network cables, and then they are, in fact, you need lot of hub devices near all the machines, and then you need all the machine to be connected to a switch, then the switch in fact connected to some gateway devices, and then some router devices. There are many things that you need, and sometimes you want to connect to a database. In that case, sometimes you need to purchase some database hardware devices, or sometimes you have to set up a new machine and set up the database in that machine. So there are many things that you want to do, and depending on the size of the infrastructure, maybe, I mean, you need the infrastructure size to be flexible. If you believe that you are going to get a lot of traffic, you must have the machine in advance. You are expecting a campaign in December, then probably you have to procure additional machines maybe in November itself, so that you will not be in a crisis. So the crisis can come across at any point of time. Maybe the traffic can grow in your infrastructure very quickly, and you may run out of resources, and if you have to add more resources into this building, you have to go and buy the machines. Maybe buying the machines can take a good amount of time, then take the machine into this building, set up them with all operating system and softwares, which is again a time consuming process. And think about, any machine can go down at any point of time. You need to take care of that. You always sometimes need to go into the data center if you want to troubleshoot some problem. The machine is down completely, so you don't have an option to access the machine from a remote place, so you need to go walk into the data center, then you need to fix the machine. And then you also want to make sure that you have a good ventilated AC and a good power backup and good internet backup. All these things are very critical because you are going to run your software application in this infrastructure. So if your software application is down, you are going to lose a huge revenue. So you want to make sure none of the machine or none of your infrastructure goes down. So you want to be extra cautious, right? This is a big headache. By now you would have figured it, especially for a startup. If they have to set up their own cloud, their own infrastructure, it's going to be a really headache. What AWS provides is, AWS is not only for startups actually. The big companies, the big shops are also using AWS. So what AWS provides is a global platform where people can build their infrastructure as their choice, right? Assume uh, you logged into AWS, you click on one button that will create a network within seconds. Maybe less than 1 second is all it takes to create a new network. Then you want to create a machine and attach the machine to the network. Again, click on another button, choose your operating system, choose your machine type and everything. Then the machine get created within 2 or 3 seconds, and the machine is attached with your network. Or now you want to create a database. Again, you go ahead, log into the AWS portal, then click on some button to create a database. The database is created. So any device that you want to create in your infrastructure, and if you want to split the network into subnets and you want some load balancers to be added in order to balance the load across multiple machines that you are using, and anything, right? Almost you want some storage devices, right? Anything that you want, you can actually get all of them as a service, and this complete infrastructure itself, you can get it as a service. The creation of network and creation of machines, attaching the machines into the network, all these things you can do it as a service. It's not a actual network that you are getting, it's a virtualized network that you are getting, but you don't really care. As long as you get a network and you have machines in your infrastructure and all the tools in your infrastructure that can be used for running your software, you are happy. I mean, you don't really bother whether it is a real infrastructure or a virtual one. You are able to run your softwares in it. That is important. So and you also get a lot of flexibility. Let's say you want you are getting huge traffic, and you want some 100 additional machines to be added into the infrastructure immediately. Maybe you can do it within minutes, right? Maybe in less than 2 3 minutes you can add some 100 machines in the infrastructure and make them part of your infrastructure, which will handle the extra load coming to your infrastructure, right? So like this you can actually have multiple machines in your infrastructure, and you can then, they also offer the options like pay as you go. Whenever you are using the machines, you pay for it. Whenever you are not using the machine, you don't pay for it. So if you have huge traffic coming, you would add some additional 100 machines in the infrastructure, and when the traffic is back to normal, you will remove those 100 machines. So if you are adding 100 machines for only 2 hours, you need to pay only for 2 hours. It's a fixed charge, hourly charge, which AWS would charge you. You don't really need to pay anything extra. So it's highly flexible. So if you have to set up the data center, you don't have such flexibility. You have to, right? If you are expecting, you need to figure out what is going to be the most huge traffic in coming to your web application. Then based on that, you have to set up your infrastructure. Otherwise, if there is a huge traffic coming, your software will go down. So you need to make sure that your infrastructure is powerful enough to handle the high load. But in case of AWS, you can actually configure your infrastructure with minimum resources so that the software will run under normal circumstances. And if traffic is growing, you would automatically add machines, and your infrastructure would become ready to handle the huge traffic instantly. And you need to pay for whenever you are using it. Got it? So You get a lot of flexibility. If you want to back up a complete machine, all it takes is only a few minutes, right? And from that backup, you want to create new machines, you can again do that within seconds. So like that, you have huge amount of flexibility coming if you are using AWS that you would never get if you go with a traditional computing. So our first project that we are going to learn, like I said, we are going to learn about WordPress and some PHP framework and some Java applications and some PHP application. And we will learn these applications during this training. And then when we move on to cloud computing, we will actually set up a cloud computing infrastructure. And in this infrastructure, we will deploy, we will create a network, we will split the network into subnets, we will create, right, uh, machines, number of machines, and we will deploy our softwares in these machines, right? And we will make sure that these softwares are highly available, they are fault tolerant, and they are scalable. So I will talk about these terms in detail. I think maybe you already know these terms since you are working from similar backgrounds, right? High availability, what it means is your software would be highly available to your people. So no matter what happens in your infrastructure, it's possible that some software may become unavailable, or maybe even some machine can go down. So no matter what happens inside your infrastructure, your software would be available to people always. That's what I mean by high availability. Fault or tolerance also has similar meaning. Basically, if one machine is going down, it should really not affect your software application. Maybe the other machine will come up which can replace the old machine which is gone. So, and scalability is what I talked about. Whenever a huge traffic is coming into your infrastructure, you should be able to instantly add more machines into your infrastructure which can handle the extra traffic. That's what I mean by scalable. So our infrastructure that we design in AWS would be highly available, fault tolerant, and scalable. That is going to be your first project. Right? And after cloud computing, we will move on to DevOps. So first I will talk about this continuous integration. So continuous integration is, okay, first I will give a brief introduction on DevOps. Think about this. Think about a software which your company own, right? There are many startups out there, and not just the startup, there are many companies, Google, Flipkart, right? They are all different companies, and they all have a software using which they are generating their revenue, right? For example, for Google.com, for Google company, it's the Google.com search engine that is generating them the revenue. Similarly, for Flipkart, it is the retail website that is generating their revenue. So there is a software product which is the core part of every business. Even if it is a startup company that takes care of the shopping, that takes care of the machines in the shopping malls, the billing machines. So that software is what generating revenue for your startup. So what I'm trying to say is every company, every startup companies, what they have is a software product which they are giving to users, and that is their revenue generator. All right. So let me ask you this. So it's very important that the software product is available to your customers. Think about Flipkart is down for 1 hour when people are trying to make purchase. Flipkart is down for 1 hour, right? There can be thousands of people browsing Flipkart.com. Not only it's a huge loss in the revenue, it's also doesn't really look good. Flipkart is a company who cannot actually make sure that the software product is up and available to people, which is actually a bad reputation. So no companies can afford their software being unavailable, even if it is a small startup. They cannot, especially the startups, they cannot afford their software product being down because there are thousands of people using that software product and it should be available to them. Otherwise, you are going to get a lot of complaints. Not just the complaints, I mean, it's a huge problem in the business. And the software product should be available to people. And also, nowadays, earlier that was the only case. Nowadays, the most popular case is the most important thing is your software product would keep on adding up with more and more features. For example, think about Flipkart.com. Earlier, they had only limited options. They had their product portfolio was very small. Now they expanded that. Then they added those information into their application retail website. Then they brought in more options like promoters and right sponsors, which would who would actually work with Flipkart and try to get the more sales. And then they added more modification in the Flipkart website. They added some payment gateway, so people can actually use any payment method, credit card, debit card, net banking, or whatever they want to use. They can use those options to purchase the products. Then later on, they implemented this Prime customer. So there are lots of changes happening to the softwares. Any software that is out there in the market, the changes are very important because your product get outdated within very few, maybe within a month it can. That is how the market situation is today. Every day a lot of new products are coming. It's your responsibility is to make sure that your software product is getting the changes in time. It is important if you want to stay in the market because there are many competitors out there who are ready to bring in a lot of changes into the software and make the software more usable by people. So in your case, as a customer, whom you would go with, the people who is offering you more features and the people who are giving you more updates, more updated version very soon you are getting. So such a software is what people love to go for. So it is important for any software vendor that they are making sure that the softwares are being changed to accommodate what new requirements which are coming in. Okay, fine. So for every company, there would be a team, development team, that who takes care of developing the software application. I think you already know this. And there would be a lot of change requests coming into every company. The developers will get it. Maybe this is a change request opened by somebody, some marketing team. This is a cab application like Uber or Ola. So this guy said, I mean, we need the Paytm payment option to be integrated in our. Uh, Basically, I mean, there are lots of people out there in the market who only have balance in their Paytm but no money in their wallet. So there would be a lot of people who prefer to book a cab using their Paytm wallet. So you want this feature to be implemented in the cab application. So a marketing guy, he said that we need Paytm payment option integrated in the application, and this request will come to a developer. And similarly, there can be a lot of requests. Your testing team, when they tested something, they found that something is not working. People from Bangalore not able to book a cab. that is opened as a new change request. Please fix this problem. People from Bangalore are not able to book a cab. Identify and fix the problem. And so like that, there can be a lot of change requests coming into and the developers, and the responsibility of developers is to keep working on these change requests. Basically, they need to make a lot of code change. Your software is nothing but it contains a set of code. So the developer need to make the code change, and finally, once they are done with the code changes, they need to update the changes to a repository. Maybe I'm going to call it Git. Git is a smart repository. Assume it's like a storage that is getting update from the developer. So whenever developer makes some changes in the software code, they will update those changes into the Git repository. Each time, each developer, when they work on something, they fix something, they will do a commit into the Git repository. So the Git repository at any point of time will contain whatever change done by developers. Not just that, think about Git tracking each change done by your developers. Let's say this is Tom. He is working on adding Paytm payment option into the cab application. And Tom fixed that problem in the code. He updated the code into Git. What Git does at that point of time is it will record whatever change Tom had made. Right? That would include which file Tom had modified, what command Tom have added, right? At what time Tom had made this change, which files were modified, which exact content were modified. All these things Git will record and it will save it. So Git not only contains the latest software code, it also contains the complete history about your software. Any developer making change into the software code, it's all being tracked by this Git repository. So think about this, your software development started back in 2000 and you are using Git ever since. So since 2000, it's 2017. For the last 17 years, whatever change happened into your software, Git is recording those changes. Maybe that start from the very beginning, the first day where you started developing your software. From that day, Git contains every information about your software. When particular change was made, who made the particular change, the complete history of commits made by all developers. You can ask it who implemented Paytm option, or you can even ask it between 2014 Jan and 2015 Feb. What are the changes happen into the software? So all this information Git can tell you very accurately because it is recording every change happening to the software code. So lot all these change requests which your different teams need to have in the software are actually practically worked out by developers. They make the code change and they update their code change in the Git repository. So think about this infrastructure which I talked about, the production infrastructure. In this production infrastructure, you have number of machines, and these are the machine being browsed by your customers. Whenever you browse for, let's say, assume I am talking about a web application, you have a web application like Flipkart, or maybe it's a retail website or whatever, or it is a cab application like Ola or Uber. When somebody tries to book a cab from their Android phone, their request is coming to your production machine and it is getting the booking confirmation from the production machine. So this code change, whatever your developers are doing, those code change need to come into this production infrastructure. All the machine in the production should be updated with the latest code changes. Then only the people in the market, that means your customers, can actually see the changes done by your developers. Otherwise, I mean, if you did not do a release process, this is called release process. It's through a release process you are bringing the changes in the Git repository to a production environment. So if you still believe that if the release process is not done yet, people who try to book a cab, they will not get a Paytm payment option. So it's important that whatever change request, whatever changes are happening in the Git repository or in the place where developer had fixed it, those code changes need to come all the way to the production. Then only it would actually become available to the market. So actually, you cannot simply just copy those code into the production. It doesn't work that way. There are lot of procedure that you need to take care before you could actually bring the code into production. You need to do proper testing, and initially the plain text code that you have, that are written by developers, they are not in a usable form. First, you need to convert this source code into a executable code. Then this executable code is what you need to execute on the production machines. But you cannot directly execute those code in the production machines. Rather, you first need to test it. You need to test and make sure that those executable files are working fine before it can be moved into production. And there is a testing team. Typically in every companies nowadays, they have a testing team. The responsibility of the testing team is to make sure that whatever changes developers are doing, they are being tested very well, and also your software product is doing what it is intended to do, and many other things also. That is what the testing team would take care. And there is a operation team. I hope you already know about them. They are the ones responsible for managing this production infrastructure. So they want to make sure that this production infrastructure is up and available to people, and whenever people browse for the application, this infrastructure is serving them. Those are the things which the operation team are most worried about. In fact, developers are worried about finishing their work. Basically, whatever change requests which are coming in, developer need to work on these change requests, finish these change requests, and make a commit into the Git repository. So there are different teams working in a company who are part of this entire process, right? And nowadays there are a lot of problems happens. I wouldn't say between teams, but actually, since each team has a conflict of interest, development team has their interest. Their interest is nothing but whatever request coming to them, just make the code changes in time and deliver the code. And they believe that they are done with it. The testing team responsibility is to make sure that whatever changes are happening in the Git repository, those changes are being tested very well, and the feedback is given to the operations or developers, whoever are responsible. So they want to make sure that whatever changes are happening, they are stable changes. The operation team want to make sure that the production is up and running. They are even ready to compromise to delay the release, maybe pend the release to the next month until some current issues are fixed. Right? I mean, all these are very valid concerns each team have. That is their job, right? That's what they need to focus on. But all team has different interest, and they can conflict at many point of time, I will tell you. uh, that's how it is today, right? I mean, not we will come to that. So assume your developers are making code changes and your testing team is testing it, and operation team get the request to bring in those changes into the production. You have production infrastructure that is waiting for changes done by developers. So the developer keep on fixing the problem. They will keep on updating the change into the repository. That's what developers team would do. The testing team has lots of responsibility. They need a testing infrastructure first, where they want to run the testing. So this testing infrastructure is something similar to production. It will have a number of machines, and into this machine you want to deploy this code in the Git repository. You want to deploy them into this testing environment. Then this testing team want to do testing, maybe using their mobile phone. They will try to book a cab and they will try to make a purchase using Paytm. Or maybe they will have some automation testing tool. Inside this automation testing tool, they will run some script, write some script. When this script were executed, it will connect with the testing infrastructure. It will try to book a cab and try to make a payment using Paytm, and it will get a response. And finally, based on what it found, they will generate a report. This test have been performed, and this test is working, this is not working. So based on that, they will create a report. So this is something the testing team would do, and maybe they are doing it like every week, or maybe the complete testing is performed. maybe on a weekly basis or whatever. So assume frequently these testing teams generate test reports, and these test reports are actually sent back to the developers, and developers would realize that okay, something is wrong. And these git commits will happen very frequently. The change request would be finished very frequently. Maybe every day there can be one or two or maybe some 10 commits made by developers depending on the size of the infrastructure, size of the software. But whatever changes are present in the Git repository, the testing is getting performed maybe on a weekly basis or maybe on a 2, 3, 4 days or maybe after 10 days, the testing is being performed and the report is getting generated. And the report is sent back to developers, and developers are getting feedback for the changes they have done 10 days ago. So think about that. There can be some 50 changes at least within last 10 days, and all changes are being tested by the testing team together. And when the feedback is given to the developers, they will have no idea where these issues come from, right? Because it's already 10 days and you have no idea. Even you know which technology, which exact code that you had worked in, probably you already know, but still you cannot really predict this issue come from that work, right? It's tough to predict. I mean, if you are getting feedback within hours, then you can predict it. But if it is after days, you cannot really predict it. So, developer need to figure out where this issue come from, and probably they need to work with others, and they need to find out what the problem is, and finally they need to fix that in the code. Identifying the problem itself would take a big deal for them if they are getting the feedback very late. And then when the issues are finally the code which is ready in the git repository is coming to the operation team, they will again cross check is all tests have been performed, and they will found that some test is missing. So some tests need to be performed. They will send it back to the testing team, and maybe they will send it back to the developers also. You need to first fix this before we can do this release, because we want the production to be up and running always. We cannot let this change that you are making breaking the production. So due to that reason, the operation team will not allow the releases. So due to many of these reasons, this release process always very slow. Nowadays it's very slow. Companies does release every month, every 2 month, or there are still companies who does release every 6 month or 9 month. Think about that. I mean, your code is actually staying in the git repository without being moved into the production for months. It's more like you are already losing a lot of business, and soon actually you are going to run out of business, because obviously there are many companies out there in the market who is giving updates to their software on a daily basis. Think about this. You have some problem, you there is a problem. People from Bangalore, they are not able to book a cab, and your developers had made the changes. What they did is they fixed the problem. Maybe for the developer it was all about a 30 minutes job. They found the problem immediately, they fixed it, they updated the git repository with their code change. But remember, it is there in the git repository, it is not there in the production. That means your customers still need to wait until you do the next release. Maybe you schedule your next release to after 2 months. Then for 2 months, people from Bangalore still won't be able to book a cab from Bangalore location, which is a wait, right? I mean, you just not only lose the business, you are actually losing a lot of customers. So it's very important that the release process should happen in time. So actually, back in some 10 years back, people really got stuck. People from the software sides, they really got stuck. All the software companies realized that this is not the way of working, because things are not working. You are not able to give things to the customer when they need it. Developers are finishing things in time, but still the release are not happening in time. So then they had some discussion how to improve this process and everything, and finally DevOps came as an answer to this question. So what in DevOps? Yes, there is a team of developers and operation team, but they work based on a same focus. I mean, by Dev, it could include your developers, your testing team, your marketing team, your business teams. All these teams combining together, I would call Dev. Ops is your operation team who takes care of all the operations. But in this case, they will not really work like a separate team, they will work like a single team with different responsibilities. So developers responsibility is to make both of their responsibilities to make sure that the software changes which are being done are going through a good pipeline process. The software code, whenever it is developed, it is tested, it is verified, it is then communicated with the right teams automatically. Then that happens for any change which developers are making. So the operation team doesn't really need to focus on setting up these infrastructure or everything. Those things would be automated in such a way that whenever developers are done with their coding, they can it will automatically initialize a series of pipeline process that would verify the change done by developers automatically. So basically, developer does not stop for operation team to do something for them. So let's say developers want to do some testing, they wait for a testing environment to be created from operation team. Then operation team is busy, they need maybe 1 week to create such a test environment. So those days are actually gone. Instead of that, what operation team would do is they would set up a environment for developers which is self building. So whenever developers are done with their job, they will just maybe call a script which would actually start a series of pipeline process that would even include building this testing environment, deploying your code into this testing environment, then testing your code in this testing environment, generating the report, verifying the test reports, and then marking this change done by the developer as a stable change or an unstable change. So all these things will happen in a completely automated way. The verification of the code change will happen in a completely automated way, so that both team does not need to have conflicts anymore. I'll tell you one example of continuous integration. Let's think about this. Your developers are making change to a Git repository, and from this Git repository, the code is automatically taken, and using some build tool, let's call it and or Maven, using some build tool, it will convert this code into some executable code. That's what you need to do. Actually, the plain text code is not actually usable. First, you need to compile it to make it a machine understandable form. Then you need to build the entire code into an executable file so that you can directly execute the file on your machines. Then this executable, you want to first deploy them in a testing environment that contains a number of machines. These machines will get updated then by developers, and now your testing team want to start testing, and maybe some testing tool is also there that also want to do this testing. And finally a report would be generated, and this report is need to be verified, right? And if the report is looking good, then this change will be marked as a stable change, or even you would want to copy such stable changes into a different repository. Maybe I wouldn't call it different repository, maybe same branch within the repository. Maybe understand, all stable change need to go into a stable place. So this storage would only contain only stable changes. And assume you have a tool called Jenkins. And whenever a developer is making a commit to the Git repository, Git is sending a notification to Jenkins. Jenkins will ask and Jenkins will first check out the code from Git. It will ask and to build the code into executable file. And once these executable files are created and they are ready, Jenkins will deploy this executable file into this testing environment. Then it will send a notification to the developers, or it would send a notification to this automation testing tool, which will automatically start testing on this testing environment. And it would do all the testing that Jenkins asked him to. Then it will generate a report finally, and this report is then read by sent back to Jenkins. Jenkins read the report, and if the report is looking good, if there are no errors, what Jenkins will do is whatever change developers had done, it would be moved into this stable place. Otherwise, Jenkins will send a notification to the developer saying that it's broken, something is not working, please fix it. After you made this particular commit, something has broken, please fix it. So then the developer will get immediate feedback within minutes after they made the change. They are getting the feedback. It is very easy for them to identify where the problem is. So that is also, you can this is called a continuous integration process, and moving the stable changes into the different branch of a on a Git. This could be an example of a continuous delivery process, which we are going to discuss in detail throughout our course. And this is going to be your second project in this course. We will take that same applications, the Java and PHP application that we had learned, right? And we will work with those application on this continuous integration project. Your last project is config management, where we will actually learn how you can build a complete infrastructure yourself in a completely automated way. So remember, you created an infrastructure that contains a number of machines. The first project on AWS is create infrastructure, and in this machine you set up the PHP application. In this machine also you set up PHP application. In these two machines you set up the Java applications. In this machine you set up the database application. So like that, there are a lot of setup that you need to do, a lot of manual installation, configuration, a lot of manual work that you want to do. This time you will build the same infrastructure in the cloud, but using in a completely automated way, using Chef or Puppet or Ansible, using one of these tools. So you will tell this tool, rather than configuring everything manually, you will tell this tool how many machine you have, and how many machines are running PHP applications, how many machines are running Java applications, how many machines are running database, how many machines are running different applications. So all this information I will tell to Chef, and I will also tell to Chef that if the machines which are running PHP applications should be installed with these many softwares, or any machine which are running Java application should be installed with these software. So like that, I need to tell Chef how all my infrastructure should look like, which file should be installed, which software should be installed in this machine, which file should be present in this machine. All these things I will tell to Chef. Then Chef will automatically configure my complete infrastructure and build it. So that is going to be your final project on config management. Right, total we have 3 projects. These are like real-time projects only. I mean, these are the projects which I work, I mean, not the exact project, but these are the practices which I work in. So the similar projects I would make you to work on, which means you are actually going to get a lot of real-time scenarios while you are doing this course, right? And everyday classes are recorded and videos would be shared with you. You will get access to the video, and the classes are going to be classes would start from next week, next Wednesday morning 7:30, right? And yeah, that's pretty much it would take nearly 60 to 70 hours of training, and 2 months we will complete in 2 months, and there is going to be lots of assignment also which you need to finish. Does this tool going to work on a base of Active Directory? Yes, they can. I mean, it doesn't
So
really matter.
Basil,
Yeah, go ahead.
yeah, sorry, go ahead.
No, what I'm trying to say is the platform doesn't really matter. Whether you are creating Windows machines, whether they are Linux machines. Though in our case, we are mostly focusing on Linux, and most of the real-time cases, the infrastructure are in Linux. That is the reason we are focusing on Linux. But basically, I mean, theoretically, it doesn't really matter. It could be a Windows environment. It could be an environment where you handle the LDAP, Active Directory. It doesn't really matter. Right? DevOps would would can be applied on any infrastructures.
Okay.
Yeah.
So, are we going to learn Linux basic commands and everything, right?
We are going to learn. Yes.
Okay. And one more question. Okay, if we get a job for DevOps engineer as an engineer, what our role in our as a position?
Uh, that is a
So if we get a job as a DevOps engineer, so what our role supposed to be?
there would be it can come from different side. Whatever we discussed, right? One thing can be configuring this continuous integration and doing the releases, right? You want to make sure that the code is going to production on a short interval. So doing the releases to make sure that the code is going live in short intervals and how to improve that process. Then maybe you would try to migrate a traditional working environment into config management using one of these tools, or sometime you want to work on some monitoring and setting up the proper monitoring for your infrastructure in case of something is missing, right? Some machines are not working or any problem with your infrastructure, you want to troubleshoot and fix the problem. There can be lot, I mean, it's not really a specific job like developers. It can come from the cloud operations to DevOps to the traditional system management also. You will have a clear idea. I mean, once we started with the training, you will have a clear idea on that. What are the exact job that you would be doing?
Thank you.
Yeah, and Kamalakar, you have any experience? Have you got any experience? Kamalakar, can you hear me? Okay. Okay, cool then. So, any other questions, guys?
I was having a question about the. You said that we need to have knowledge about the Linux systems, right? So
Mhm.
does it goes by that we need to have the extent level of the knowledge, or it is something like we can just operate to work with the tools on the Linux?
You need extended knowledge. It's not just that the tool that we are going to run on Linux. Apart from that, the infrastructure that you are going to manage would contain a lot of Linux machines. So having a good knowledge on Linux will help. Actually, we are covering enough. I mean, you don't really need, for now, you don't really need to focus on learning Linux. You can stick to our course, but just make sure that you are going in the flow. You should be very clear about the Linux administration and the networking topics before we move on to the later stages like cloud computing or DevOps. That is important. But for now, let's not focus on. I mean, I will tell you what things you need to do on a daily basis. You can stick to our training. No need to take any extra Linux classes.
I understand. Thank you for that.
Sure. Okay, cool then. So let's the class will start from Wednesday, 7:30 a.m. IST. Right. Thank you.
How many days the class is going to be? I forgot to ask that. Sorry.
It would be weekdays, Monday to Friday, and I'm expecting we need nearly 45 classes.
I understand. What's about the comment? Like, is it going to be in the weekend, something like that, or it's going to be daily on the?
Mhm. It would be weekdays, Monday to Friday, everyday class per day, 1.5 hours. And the scripting classes we will conduct in some weekends. And there would be total 4 weekend classes, 4 or 5 weekend classes, which I will let you know when it's going to be held. Generally, the classes are from Monday to Friday. If there are weekend classes, I will let you know in advance.
I understand. Suppose because of some job functions over here on call, something like that, if I miss the classes, can I go by recording? Will I receive some recordings of the class? How it works?
That should be fine. That is the reason I am giving recording. If you miss any class, just make sure that you're watching the video on the same day.
I understand.
So is every day is 1 hour or 1.5 hour, 2 hours? How many hours in a day?
It's 1.5 per day.
1.5 per day. Okay. So we are learning a Linux from the basic to extend level, right?
Right.
Because I don't have any experience from the Linux.
If you get a chance in the next few days, just go through try to get a Linux machine and try to run some basic commands, which would be helpful. But anyway, we are going to do that. So
Yeah, because like I don't have any experience, so I don't know where to start from. So if it's better if we can go through the basic